In this tutorial, you will learn how to use the tracker software in analyzing freefall motion. So open the tracker software and upload the video file. So open file, select any of the movie files. The video file is long. What you only want is the range of motion where free fall occurs. So what you can do is to select those set of frames by looking at the frames each time. To start at the moment the ball is dropped, we select this frame, frame 233. This will be your start frame, and then set the time 0. And then select the end frame once the ball reaches the ground. So right click, set end frame to slider. This is frame 263. If you play the video file, you already selected the range of motion which you want to analyze. So after selecting the set of frames, go to the construction of origin. You can put the origin at the position of the ball being dropped. Select this button, select calibration stick, and using the calibration stick, you measure the distance between 2 points. So these are your markers. So press shift, left click, shift, left click, check whether the endpoints correspond to the markers, and change the length of this, which is equal to 50 centimeters or 0.5 meters. You're now ready to track the ball and measure the distance for each distance traveled by the ball for each frame. You can deselect axis. So press create a point mass. So let's say we rename this as ball. Press shift control, then select a snapshot of the ball with high contrast. You can see that the template has dark region. So this dark region is the edge of the ball, and this lighter portion is your background. So tracker will locate this template. So if there is a match, you just click search. So for the next frame, it will again check or compare the template with the match image. So just search next, click search next. So check whether it is consistent with the location or edge of the ball. Search next up to the last frame. Once you're done, press close. Now you have here the X location. To look at the values that you want, you can plot to So instead of x, we are interested with the y location and the acceleration in y. So we select AY. Okay. So if you now replay the processed movie file, you can see the position of the ball analyzed by the tracker. So after that, you can post-process your Y data. So your Y data is parabolic in shape. So it means that the motion is accelerated. Of course, this is free fall. So you can analyze this. You select parabola. So the value of A here is 4.42. Freefall motion is described by kinematic equation given by y equals y naught plus v naught t minus 1 half gt squared. We can calculate the value of g based on the two methods. So for method 1, using curve fit, coefficient of t squared in the equation of the parabola gives you 1 half of the value of g. It means that g has measured value 8.848 meters per square second. For method 2, we use the assumption that when the ball is dropped, its initial velocity should be 0. The initial velocity here is 0. However, from our curve fit, the initial velocity is negative 1.715 meters per second. So if we apply the condition that the initial velocity is 0, the equation for free fall is written as y minus y naught 1 half gt squared, where y minus y naught is the change in height from the launch point to the ground, and t is the time of fall from y0 or y naught up to the ground. So we can get those values from the table. So we have here values x and y, but we are only interested in the y component and t values. So we can select initial position and final position, copy this value, and then final point. So let's hide these values. So this is your initial point, and this is the final point. T1, T2, Y1, Y2. So notice that we only selected this point as the initial point. You can choose any of these points, and then the final point, 0.6. So to calculate delta, you just get the difference. T2 minus T1. For height, Y1 minus Y2. So these are the values that you want to put in this equation in method 2. So that G is equal to 2 times Y minus Y naught divided by T squared. Okay? So the acceleration is negative 2 times the change in height divided by the square of the change in time. So we get a value for G as 15 meters per square second. So these are the two results using 1 and 2. And the theoretical value for G is 9.8 meters per square second. To calculate the percent error, you have the theoretical value minus the experimental value divided by the theoretical value times 100%. So if you look at the plot for AY, the first point corresponds to the third point in Y. So it means that you need 3 points to get a value for Y. Of course, the first derivative of Y gives you the velocity. So you need 2 points there to get a value for the velocity. And then for acceleration, you need to take the derivative again of the velocity. So it means that in Y, that's the second derivative with respect to time. You can also look at the raw data. So press table, check AY. We can hide X. So we only have Y and AY and compare the values. So A only appears after 3 values of Y. So the difference between our methods 1 and 2 is that it considers all data points in Y. Unlike number 2, we only considered 2 points. You analyze less number of data points for method 2 compared to method 1. The more samples you measure or the more experiments you perform, the more accurate the value that you will get. This tutorial will be your guide to analyze 2 video files using tracker software uploaded in the site.